Today we will talk about DTFT in Matlab. So this is the example of DTFT. Determine the DTFT of a finite duration sequence xn. So this sequence xn is equal to 1 when your n number equals to 0, 1, 2. 0 for others, which means we have 3 signal 1, 1, 1 at the n 0, 1, and 2. So normally we will do the solutions by apply the DTFT formula. X exponential j omega equals to summation n equals to negative infinity until infinity, and we will substitute our xn into the equation exponential minus j omega n, and we will get this answer. So the answer is exponential minus j omega bracket 1 plus 2 cos omega. But in Matlab, how we do? So this is the code of the just now question DTFT. So first we will let our x, which means our signal, equals to 1, 1, 3 bracket. So this x 1, 3, which means we plot the number 1 at the column 1 at the row 1, and we have 3, 1, 1, 1. Then we will have our omega equals to negative 2 pi until 4 pi. And the interval is 0.01. Now we will set our frequency. H equals to frequency x, 1. The x is the denominator and the 1 is the numerator, which means 1 divided by 1. So the frequency in bracket the omega which means the return of the frequency response vector h at the normalized frequency supplied by the omega. So now we will plot our frequency response by using subplot 2, 1, 1, which means we plot two graphs in the one figure, and we have a 1, 1, which means the matrix 1, 1 for the first column and first row. Then we plot omega divided by pi. This modulus, our h, our frequency response, and we have grid. Grid, which means we draw the line in the graph, the grid line in the graph. And we have the title magnitude response. And we label our x-axis as a omega divided by pi. And then we plot for our phase response in subplot 2, 1, 2. So 2, 1, 2, which means we have two figures, and at the first row, at the second row, at the first column, the title is phase response, and we label it omega divided by pi. So now we will run our code. So we highlight the code and we click, right click, evaluate the section F9. So you wait a while. Now it's in busy. And the figure 1 will become out. So this is the figure 1 result. We have a magnitude response curve for our signal, and we have the phase response graph here. So this is our graph. Okay, now we go to second question. Second question is when we want to plot a graph for DFT. So for this question, example DFT, example given xn equals to 1, 1, 1 and 0, 0 for the signal. Now we want to sketch the xk frequency response for the magnitude response and phase response. So in Matlab, when DFT, we were using FFT in the functions. So how we want to plot this graph? Now we go to Matlab. So in DFT, for your information, we will have when your workspace command window had a lot of information that you unwanted, you can run this code, CLC, clear all, close all. It will pause all the figure and it will clear all the unwanted command window and workspace. That's it. Now we will plot our graph that for DFT. So first we have the n number equals to 5. So our signal is 1, 1, 1, 0, 0. Okay. Then we plot our graph in figure 1. Subplot 2, 1, 1. Then we plot it in a stem. It's a discrete graph. And we will have 0 until n minus 1. So this is our summation. Okay. So summation n equals to 0 until n minus 1. So absolute, our absolute, which means our magnitude. So FFT, our FFT equation or our FFT function, bracket x, and this is the graph for magnitude. Then we also plot for the graph for the phase response. And here we just have to change the angle, change the absolute to angle. So we will plot for the phase response. That's it. Right click, run. So we will get our graph in magnitude response. So at here you can see, you can click at your workspace, you can see your x value is 1, 1, 1, 0, 0, and you can click your n, so your n is equals to 5. Okay, that's all. Thank you. Bye. Remember to subscribe my channel.